Welcome to the video for the practice test. It's actually just a solving story problems worksheet, but really it's practice for our test for Core 2. We did the work on November 2nd and November 3rd, and our test will be tomorrow, November 4th. Problem number 1 is just a proportion problem. There is no triangle here. So I'm looking at the proportions. First of all, I look for keywords like how much. That tells me my X value, the unknown. How much saturated fat does he eat in 2 days? There are 3 grams of saturated fat in 1 serving of peanut butter. There are 40 servings in a jar. Mr. Burton uses a jar of peanut butter every 9 days. So I start with my X, saturated fat. And I compare that to, in that same sentence, it tells me that X is related to 2 days. So I put the 2 there. I need a known ratio. I'll have another ratio. And I want to compare days to days. So I want 9 over here, 2 days, 9 days. And in 9 days, I get 40 servings. I get 40 servings. But each serving has 3 grams of saturated fat. So I need 3 times 40, which is 120. So I'm going to rewrite that. X over 2 equals 120 over 9. And a lot of people like to cross multiply. I already have my X where I want it. So I'm just going to halfway cross multiply. I'm just going to multiply both sides by 2. 240 divided by 9. 2 times 120 is 240. 240 divided by 9 is 26.7. And actually with grams of fat, it's just as good to say 27 grams. Well, problem 2. Problem 2 is also a ratio problem. And this one is talking about a recipe. So we have a recipe that normally feeds 8 people. We're going to have a party, there are 22 people. We need to know how much flour we need to put in the recipe. So typically we use 2.5 cups for 8 people. We're going to get to the how much flour. It's going to be X. I'll put X in the numerator. Flour is going to be in the numerator. And I want to compare that to the number of people that, whatever that number is, it has to feed 22 people. So put people in the denominator. And I compare it to my known ratio, 2.5 cups and 8 people. And I'll keep people with people. So I'll put the 8 in the denominator. And I'll change my 2.5 to 2.5. And at this point, once again, I can cross multiply. I'll cross multiply this time. So I will rewrite this as 8. X equals 2.5 times 22. Equals 55. And now I divide. If you cross multiply, you have to divide. The 8 divided by 8 turns into 1. 1 times x is just x. And 55 divided by 8. 6 times 8 would give me 48. That leaves 7. 7/8 is about 9. I'll say it's approximately 6.9. Question 3. Question 3, we now start having the triangles. And we have a story problem. Part of the challenge here is picking the math out of the story. In this case, it just talks about a statue honoring someone we don't know about. It tells us where it can be found. And then it says, use the information below to determine the unknown height of the statue. So the information we're looking for is really in the picture. But we do know that we are looking for the height of the statue, and that's x. If I look at the triangle, there's some kind of reflection here, probably a lake or a pond. Look at the reflection, forms the light from the top of the statue to the eye, forms two similar triangles. The two angles have to be the same, since it's reflecting. That's how light works. And I look at the two triangles. Once again, I'm going to start with what I don't know. I have my x. And I'm going to compare that to a side on the same triangle. And then I look at corresponding sides. So if I look at these triangles, these angles are the same. The side across from this angle corresponds to the side across from this angle. Or you can think of it in terms of this triangle, 1.8 is the shortest side. And in the big triangle, x is the shortest side. So I want those two together. And 4 is not the shortest, but it's not the longest. 2.4 is not the shortest, but it's not the longest either. So 4 corresponds to 2.4. And if just so I'm not going to cross multiply, x is already where I want it. I don't have to get it out of the denominator. And I know I would just have to divide again by that 2.4. So I'm just going to say x equals, and I'm going to change this to 18 over 24, an equivalent fraction. And then I will reduce that to 3 over 4. So this is actually equal to 3 over 4 times 4. X equals 3 meters. And I do say meters since we're given the information in meters. Problem 4 is also a similar triangle problem. And also talking about a situation where we have similar triangles measuring the height of something. In this case, it's a little more challenging though. The story, a lot of the story, it's not a very well worded story, so you have to pick things out of the story. The first part just sets up the context. It talks about the building. It talks about Trisha measuring the height of that building. But the information actually starts here. She measured the distance between the tree and the building, found that it was 30 meters. So I'm going to label that right here, from the tree to the building. She stood in front of the tree and started backing until she could see the top edge of the building from the top of the tree. So we know there is her line of sight goes directly from her eye to the tree to the building. So I actually started drawing my triangle based on that. She marked her place and measured it from the tree. It was 5 meters. So from Trisha to the tree is 5 meters. I need to form triangles here, and I am going to start my triangle. I'm going to draw a horizontal line at Trisha's eye level, not at the ground level, because everything is measured from where from the point that she is looking, so her eye level, which complicates things a little bit. I know we're looking for the height of the building, but I don't want to work with that right now. I'm going to say x is this side of the triangle, and I'll come back to that. We know her eye level is 1.6 meters, so I can call this 1.6, and the tree is 2.8, which I'm not going to label yet because that's not actually part of our triangle. The triangle we're going to use runs along the tree, but it is actually 2.8 minus 1.6, because our triangle does not include the entire tree. So triangle with a side that I'm going to use to get what I want, and I have the other side of that triangle, which is actually 35. 30 plus 5. So I can start, once again, I start with what I'm looking for. You can start with something else. There are different ways to solve this. You're welcome to do that, but it works out best for me to have the variable in the numerator. And I compare that to a side of that same triangle, the large triangle. That's going to be this side, the 35. Now I look for corresponding sides. If I put the same triangle here, I need the corresponding sides to be both in the numerator and then corresponding sides in the denominator. X is the shortest side. It's also across from this angle. So that is going to correspond to 1.2, which is the shortest side in my small triangle, or the side across from that same angle. I'll have 1.2 over, in small triangle, the side that corresponds to my 35 is the 5. There, 35 is not the longest side, and it's not the shortest side. 5 is not the longest side, it's not the shortest side. So 5 corresponds to 35. Now, I'll cross multiply this time. We do it over here. 5 times x equals 35 times 1.2. And now I'm going to, since I've cross multiplied, I have to divide. I shouldn't draw my line all the way across though. I'm going to divide both sides by 5 so that I get x by itself. 35 divided by 5 is 7. 7 times 1.2. Sometimes 1 is 7. Sometimes 0.2 is 14. 8.4. Unfortunately, that's not my answer. A lot of people will stop there. The answer actually, though, is the height of the building. So I'll say the height equals 8.4 plus 1.6. Because x was only this part of the building, I have to add the part that we subtracted. The height equals 10 meters. In problem, actually the second problem 4, so actually problem 5, this late was the one I did the worksheet. I'm now given a story problem without a picture, so I have to come up with a picture. Fortunately, it's a fairly short story problem, so I'm going to start drawing things that I see in the picture. Tree is 24 feet tall. If I have a tree, I need the ground. And I'm not trying to make a very good tree. I just need something to represent a tree. Casts a shadow that's 12 feet long, and it doesn't have to be to scale, but if this is 24, well, it's going to be about half as long as that. So I'll try to get it pretty close. Brad is 6 feet tall. And his shadow, which is going to be at the same angle, is what we're looking for. How long is Brad's shadow? So I'll put the X there. Brad is 6 feet tall. So in this triangle, I have the side I'm looking for. I have the 6. Here I have the 24, and the shadow is 12 feet. So when I write the proportion, I start with the x, and I look for corresponding sides. X is the shortest side. It's also the side across from the angle of the sun, and 12 is across from the angle of the sun. It's also the shortest side of this triangle. So I want x and 12 to both be in the numerator. 6 is the vertical side, 24 is the vertical side. They're both the medium side. They're not the longest side, but they're not the shortest side. So 12 corresponds to 24. And I can reduce that to 1/2. Here I'll multiply by 6. Multiply by 6. And so x equals 1/2 times 6, or 3. So the problem that was labeled problem 5 was really problem 6. Once again, a word problem. I have a flagpole, casts a 25-foot shadow. And in this case, I'm going to not draw as much of the picture. I'm actually going to draw the flagpole. I'll draw it just as a straight line. And its shadow, again, the shadow is going to be less than I draw the length of the shadow to be less than the 40, because I know from the story that's the shortest side. I have a building 200 feet tall, and I'm not going to try to draw a building. I'm just going to call that side 200. And then I will draw in, once again, draw in the other sides. Not trying to actually make it look at it like a building. I'm just going to draw them as triangles. Sometimes it helps, if it helps you to actually draw the building, actually draw the tree, you're welcome to do that. That's how I like to do it. For some people, though, I think it can be confusing. So we just draw the triangle. This is a building, this is the shadow, this is the sunlight coming down. 200, and we are looking for the length of the shadow. This is my x. So I will set this up. I'm going to put the x over something from the same triangle, 200, and look for the corresponding sides, the shortest side and the shortest side. I want the corresponding sides together. So I put my 25 in the numerator, since I have the x in the numerator, and I put my 40 in the denominator, since it corresponds to the 200. And at this point, to talk quickly, some of you I've seen doing problems like this, which is fine. Different ways of doing this. I'm going to show you a different way. Some of you are comparing the short side to the short side with the ratio. If you do that, short side, short side, then you compare the medium side to the medium side in the other ratio. And you'll see when you cross multiply, actually I'll do this one by cross multiplication. I'll multiply 200 times both sides. And multiply 40 times both sides. I'm just going to show that this way. 40x equals 200 times 25. And since I cross multiply, I have to divide. Forties cancel here. And 200 divided by 40 is 5. 5 times 25 is 125. And this proportion, set up an entirely different way, I'm going to just multiply by 25. I could cross multiply, but I like to show you both ways to do it. And once again, you see I have 200 times 25, 200 times 25, and I divide by 40. Either way, I end up doing the same thing. No matter how you set the proportion up, you end up doing these same calculations. So once again, I get 25. I'm sorry, 125 times 5, which is